My name is Raphael Cassia. I am the chair of the Audio Engineering Society's South German section, and it is my great pleasure to welcome you all to this event. If you're interested in joining the AES, joining the section events, or being notified about upcoming events, please see the links and QR codes that we've just shown. They'll be available later in the presentation as well, or at the end of the presentation. But without further ado, I'd like to invite Elena Shabalina, who is in charge of organizing the colloquia, to say a few words and introduce our speaker. Thanks.
Hi all, it's really good to see you all here. I'm Elena Shabalina, I'm with DNB and do applied research there, and for AES I take care of the Colloquium and the South German section. The goal of the Colloquium is to provide a platform for all the audio and acoustics professionals and researchers in the area to interact, to get to know each other, and to present their research in a very friendly way and less formal than in a regular conference. And what we explicitly encourage here is asking a lot of questions and asking questions that one doesn't dare to ask at a normal conference presentation. For example, this is not your field and you think you're missing something essential, then please feel free to ask. And we especially want to encourage a discussion after the presentation. So this is the second event of this series. We aim to do that every month, every third Tuesday of the month. This one is a special event because of the master thesis deadline. Today our speaker is Lukas Benedicic, and he's a sound designer and a musician, currently finishing his studies at the Fachhochschule Joanneum Graz and the University of Music and Performing Art in Graz. His academic journey started with musicology, where he got his bachelor's degree, and between his bachelor and master's studies he completed an audio engineering course which certifies him as an audio engineer. Besides the formal education, he tries to stay busy improving his skills, whether it be sound design related or musical. So welcome, Lukas. We are looking forward to your talk.
Okay, hello, thanks. Yeah, it's my presentation of my master thesis, which is about audio production in the context of stereo-upmix-capable playback systems. So why this topic? I'll start right off with the buzzword immersion, which is kind of a hot topic right now in audio, and it's also an exciting one, I think, since there's much development happening at the moment, and yeah, it's just exciting, I would say, at least for me. Most of the time when we hear about immersive audio, it's about 3D audio, and even if it works really well already, the establishment into the mainstream is not really there yet. And I think there is, this is related to some drawbacks, all still being a problem, which is in respect to 3D audio format compatibility, because a lot of formats need a certain decoder or big loudspeaker setups with a lot of loudspeakers. And another drawback is that there isn't that much content available at the moment in 3D audio formats. So that makes it kind of unattractive, I think, for most of the people in the consumer area. And yeah, and since stereo is still one of the most, or if not the most format in the consumer area, one question was what can be done with stereo regarding immersive audio on loudspeaker playback, because it only makes sense if the audio content works in normal stereo production and in the context of upmixing technologies, because otherwise it would just be another format with special needs, so to say. And I want to establish an universal things, more or less. So therefore, I produced a piece to further gain information and experience. Before that, I analyzed, but we will get to that. And I focused on the Amazon Echo Studio smart speaker, which is one of the first, if not the first, commercial 3D audio and stereo upmix capable smart speaker. And yeah, it's surely the most popular of this kind. So it made sense to focus on that particular speaker. And before I dive into the analysis part, I want to show you some concepts which are important to understand in order to understand the topic better. So the first one is correlation and decorrelation, which expresses the amount of phase differences of dual channel signals, and it's a very important aspect regarding our spatial sound perception. And it also has a great influence on the perception of the width of audio signals. And it can be expressed from numbers -1 to 1, where 1 means the signal is perfectly correlated, which means that we perceive it in a narrow stereo field way, in a mono experience. 0 means that the signal is decorrelated, that there is no correlation, which means the phase is completely different on both channels, which results in a broad or wide stereo image. And -1 means the phase is inverted, so the signal, the signals would cancel each other out, and yeah, it's just that. From a production point of view, this means that positive numbers are monocompatible and negative numbers are problematic, because there would be significant cancellations when playing back the signal. And I have a short audio example where I have a mono recording decorrelated after a few seconds, and then it gets back to mono. So you should hear from mono to stereo effect.
I know the season's ripe for change. It's changing all around. I know the reasons you've arranged. They're tearing me down. Where is the peacefulness of mine?
So I hope you could hear it. The next concept or two terms which were pretty prominent in my thesis is apparent source width and listener envelopment. They are generally used in the context of acoustic, for the description of acoustic qualities of concert halls, where apparent source width describes the width of the sound source, and the listener envelopment, as the name already suggests, describes the envelopment of the listener. And both terms combined describe the whole spatial sound experience. So the apparent source width describes the direct signal, and the listener envelopment describes the later arriving diffuse reverberations. And both phenomena are mostly dependent on correlation. So the more correlated the sound is, the wider the experience. Those two phenomena are dependent on some other things, but the most important aspect is the correlation. So loudness, for example, plays another role, or the spectral, the frequency spectrum. Okay. And now to some general things about soundbars and smart speaker. Briefly, those devices, as I said, are more and more popular, and some of them have those spatial enhancement functions or are 3D audio capable. So, as I also mentioned before, but I say it again, they could be a vessel, maybe, or a vessel to bring spatial audio into people's living rooms. And yeah, I think we have to wait and see about that, but it's a chance. So for everybody of you who don't know what the difference is, simply put, sound bars are generally elongated speaker arrays with multiple loudspeakers built in, and they are often used in combination with TV. And smart speaker can also be equipped with multiple speakers and are mostly controlled with a voice user interface, like, for example, Amazon Alexa. Yeah. So, okay, and regarding the spatial audio reproduction, there are two technologies common in those devices: beamforming and crosstalk cancellation, where the beamforming is the most common technology used in those speakers. This means that directional sound is emitted on flat surfaces, preferably, and then gets reflected to the listener. So therefore, it's possible to hear sound from above, for example, even though the speaker is in front of you, because of the reflection, which is also called phantom sound source. And yeah, this is possible on one hand because of the way the speakers are built or directed, and on the other hand, and this is the actual beamforming, it works with constructive and destructive interferences. So there are cancellations where sound doesn't have to be, and constructive waves where the sound should be. And so it's possible to directionally send or beam sound, to use that word. And of course, there are some drawbacks with this technology. Since rooms are not standardized, there is also always a dependency on the room conditions. So for example, a well-treated audio studio would not be a great environment for this kind of playback systems. Okay. The next one, it's used, but there are not that many products which uses this technology. But just for the sake of showing you, the concept behind the crosstalk cancellation is to reproduce binaural audio signals with loudspeakers. So in order to achieve a proper sound experience, 3D sound experience, you have to cancel or send canceling signal to the ear, which is opposite to the side of the speaker for the right ear, and vice versa, so that only the right ear, for example, hears the signal from the right speaker. So in theory, that it's perfectly possible to achieve a 3D audio effect with binaural audio signals played back over loudspeakers. Okay, and now what is upmixing in general? It's the process of transforming or converting audio signals of a lower channel number to a higher channel number. It gets bigger, so to say. Most common is stereo to 5.1 surround sound upmix. And of course, there are a lot of different ways to accomplish this, but most of the time, it's the same general concept behind upmixing technologies. So I found a quote which addresses this. The quote is from Burki and his colleagues. Upmixing methods differ in how they separate the directional and diffuse components. So in the upmixing context, audio signals are composed of direct or primary components and diffuse or ambient components. So the direct parts are the correlated parts of a signal, and the diffuse parts are the decorrelated signals. And yeah, for example, in a stereo to 5.1 upmix situation, the direct signal would be reproduced by the front loudspeakers, and the diffuse parts are reproduced by the corner speakers, for example. And this, yeah, it sounds like not that complicated, but in reality, it's complicated because there are not only technological difficulties, there are also definition problems. What is ambience exactly, and so on, but I'm not going into that. And now we're coming to this thing, the Amazon Echo Studio, which I focused on. It's one of the most popular, or the most popular 3D smart speaker, which was released at the end of 2019, and supports formats like Dolby Atmos or MPEG-H, for example, to name two object-based 3D audio formats. Those are accessible, for example, via the Amazon Music HD streaming service, where there are currently about 1,000 songs or so available. So not that much if you really want to listen to your favorite music and so on. The speaker is controlled with either Alexa or with the smartphone. And there are 5 speakers built in. 4 are directional and 1 subwoofer, 2 side speakers, 1 on the top, 1 vertical speaker, and 1 high tone speaker at the front. And yeah, it works with beamforming, as I mentioned earlier. And I started with my analysis, which is, so to say, the core of my thesis, to find out how the upmixing, or rather the behavior of the loudspeaker, works. I microphoned the 4 directional speakers. I ignored the sub speaker because there is not really directionality going on. And yeah, I used pink noise in different versions, meaning mono, stereo, and side signal only. And so I have, from the correlation point of view, all three extremes, because mono is the negative, the one correlation, perfect correlation. The stereo pink noise is 0 or about 0, which is decorrelated, and the side signal only is -1. So I focused on the correlation aspects the most regarding this first analysis, since, as I just said, it is the common upmixing concept to focus a directional primary sound signal, which is the correlated part of the signal, and the diffuse part, which is the decorrelated aspect. And so, playing back these three different kinds of signals, I could see which part of the signal gets distributed how much on each speaker. And yeah, I did the procedure always for the activated spatial enhancement function or upmix function, as well as for the deactivated, to have something for comparison. And yeah, briefly about the results, so to say. First, the pink noise in mono with the activated upmix function. Here were all speakers active, where the front speaker was dominant and the vertical speaker almost not active. And the correlation between the speakers was, as you can see in this image, quite good. I used, by the way, the correllometer by Oxengo, which splits the frequency band up to 64 parts. So you can see the correlation values for the whole frequency spectrum. And it's a free plugin, by the way. So you can see it's quite correlated here, and the correlation is between the two side speakers. I just show you how a mono pink noise sounds. Okay, and the next one, this is stereo. Or at least it should be stereo. Here also all speakers were active, but the big difference was that the vertical speaker was much louder than the front speaker, so the opposite of the mono playback. And yeah, in general, all speakers were active again. And I also tested a gradual mono to stereo shift, and there I could also see the gradual activity shift of the front and the vertical speaker. So something important for my production. And as you can see, the correlation between the side speakers is quite heavy in the negative areas, with a peak around 2K. And yeah, and then the side signal, here were only the two side speakers active. And what's really strange is that both speakers correlate. So you would expect the opposite because the side signal is -1 in general. So one side seems to get inverted, and yeah, but I don't actually know why this is the case. Next one. And then I also analyzed the panning behavior of the upmix function. I panned pink noise in mono, hard left and right. And unlike normal stereo systems, the Echo Studio with the activated upmix function doesn't work with amplitude panning. Instead, it works with a mixture between phase-based panning and spectral panning, which means there is no significant loudness difference between the side speakers, even if it's hard panned to one side, for example. And this is achieved with phase shifts and filtering. And you can see at the images, the image on the top is a hard panned graph. So the green one and the red frequency spectrum are the two different speakers, and you can see that the spectrum is quite different opposed to the picture below where the panning is in the middle. And you can also see down at the correlation meter that there is some phasing going on. Okay. Then the deactivated upmix function, I did the same procedure again, and the results are quite unspectacular because with the deactivated upmix function, only the side speakers are active, and it just behaves like normal stereo reproduction system. So amplitude panning, mono correlates, the side signal is -1, and so on. And then I started to get a little bit more practical in a way. Then I started to analyze some musical examples. Most of them are pop songs. I think pop songs are probably the most common audio content played back on those devices. And I looked for passages of certain pieces where I thought that work good in the upmix, the activated upmix playback. And yeah, I analyzed the songs about the sounds and the production. So I analyzed the decorrelation and the instrumentation and what kind of sounds are better or have a better spatial effect, what doesn't work that great, and so on. And in the end, I had an impression what works, what works not so good. And then I analyzed the actual listening experience of the playback. And first of all, I thought about what kind of room is representative for this. And yeah, I measured the reverberation time, and I even found a source stating that the time is representative for a living situation, for a living room type of situation. So that was quite good. It was my bedroom in this case. And then I recorded binaural. I made binaural recordings from the listening experience. You can see in the image my room. The red one is my listening position, and in the middle is the Echo Studio, and the squared things are studio monitors, which I also recorded as a reference. Yeah, and I recorded once again the pink noise types and the musical examples, and this with activated upmix, deactivated upmix, and the studio monitor. These recordings were then analyzed with the correlometer once again, so to objectify the apparent source width and listener envelopment in a way. And the results showed that the playback of the mono signals with the activated playback with the activated function are perceived the most correlated. So there's the most clear, narrow sound happening here, which is quite good. And the studio monitors was the bottom end, so to say. Here, even the mono signals were quite decorrelated. And when playing back stereo content, also the upmix playback system was the most decorrelated. So in summary, the playback with the activated upmix function shows the most difference between mono and stereo, which results in a clearer resolution of the stereo image. Yeah, and the studio monitors were always quite decorrelated, even in the lows, because there are two low frequency emitting speakers in those, and the Echo Studio just has its one core sub speaker. And yeah, I mean, bass is in general mono, so it's a good thing that it's not decorrelated. Also important to mention is that because when the upmix is enabled, also the top speaker is enabled, which lets you perceive sound from above, which of course also improves the listener envelopment. And all these analysis and so on, I could in the end break down to 4 bullet points or guidelines, if you will, regarding audio production qualities that work well with the upmix function of the smart speaker. So they are decorrelated productions and sounds, spectral dense atmospheric sounds, so with a lot of tonal information, reverb and delay, and binaural atmospheric sounds or pads. And ongoing with these results, I produced my piece. The production, which consists of 6 different parts, to have a bigger variety of sounds and different kind of listening experiences in general. And I tried to play a bit with spatial contrasts to make the upmix function as perceptible as possible. So I played with quite drastic changes between mono and stereo. And during this process, I realized that this contrast is not only achieved with switching from mono to stereo, but it's also a matter of composition and arrangement. So changing from big and wide sounds to small, dry sounds or sparse sounds makes a huge spatial difference regarding the listening experience with the Echo Studio. And yeah, so I put the composition and arrangement as a fifth of my guideline bullet points. And I'm gonna show you two parts of my composition. The first one is the second part of the composition. Here the concept was, so it's in general the widest part of the composition, the most decorrelated part. And here I tried to get everything as immersive as possible with the smart speaker. So this was quite experimental. For example, I realized when I use a ping pong delay on the snare, for example, the delayed signal has a nice spatial effect. So I recorded the delay signal and used those samples and put them onto each other and phase shifted it, which improved the spatial effect further. And yeah, I did that with the hi-hats, for example, too. And I also, for the atmospheric pads, I used binaural panna, and yeah, general used phase shifting tools and so on, just to get everything as spatial as possible. And yeah, I'm just gonna show you a bit of this part. Obviously, you don't have a Echo Studio at home right now, probably, but anyways, you can hear that it's quite wide. Okay, that's enough for now. And then the third part of my composition, so the other part I'm gonna show you, this is more conventional from a production point of view. Here I tried to find a balance between spatiality and the spatiality on the Echo Studio and monocompatibility, so that it works in all kinds of reproduction situations. Because the part B I just showed you is not really monocompatible. So here I stick to normal conventions like keeping the snare in the middle, the bass is mono, and so on. And with the other sounds, I tried to enhance the side signals, for example, and just finding a good balance between making things spatial and also keeping it compatible for other playback systems. A short and in this demonstration piece, it's first mono, and then when the whole band, so to say, kicks in, then it gets stereo. Okay. And then I'm about to conclude. So in general, there were quite good results achieved regarding the immersive feeling with the Echo Studio. And in the context of for audio production in context of stereo-capable playback systems, upmix-capable systems, it has generally to be thought about, is the produced content only made for this kind of technology, which I also mentioned in my introduction, or should it be produced in a way that it works for every kind of stereo playback or even mono playback? And of course, from a practical and commercial standpoint, the second option makes more sense. And yeah, in order to work as a normal stereo content, one should pay attention to not overdo it with the spatial, with the decorrelation and stuff. And yeah, most of the results of my bullet points are quite universal, I would say. So they are not only applicable to the Echo Studio. And I would say that many producers, so to say, produce in or for upmix-capable playback systems anyway, because the things like enhancing the side signals for more for a broader image, or reverb and pads for enhancing room is not a secret tool in audio production. But in the end, I think the topic and the technology has quite a potential, and I don't know how to how to conclude, but yeah, maybe it's just a good thing to think about this kind of technology as well when producing. And I think that this thesis can probably be a good guideline for spatial stereo productions. And it's also a matter of being conscious about producing audio content, whatever the playback situation may be. And for now, the stereo format is still the most common one. I have a short summary of the whole composition, which lasts about 1 minute or something. Thanks.
Mono is cool, but I want stereo.